arc length and sector area. The arc length and the sector area are basically just portions of lengths and areas of a circle. Basically, the length of an arc represented by L is of an arc that's measured in n degrees, in which the circle's radius r is equivalent to the product of the fractional part of the circle contained by the arc of the circumference, blah, 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 blah. Okay, so what does that really mean? Well, an arc length is basically just a portion of the outside circumference of the circle. If you look at this circle here, arc AXB is actually just this portion of this outside perimeter or circumference of the circle. Well, circumference of the circle is measured by pi d, or pi times the diameter of the circle. Now, the portion of the circle I'm talking about is measured by how many degrees it is, which we're using the letter n to represent. So since I'm talking about n out of the 360 degrees of the circle, if I multiply that ratio times the total circumference, that'll give me the length of the arc. Similarly, the sector area of the circle, sector area is basically the area of this shaded region that I'm shading in here. If I want that area, I could take the total area of the circle, which is pi r squared, and again multiply by the ratio or the fraction of the circle that I currently have, which is n degrees out of 360. So an example of how we could use these formulas, given the following information, I need to find the length of arc PAQ and the area of sector PAQ. Given that the radius is 5, so I know the radius is equal to 5, and PAQ, this arc, measures 300 degrees. So let's do part A. The arc length is equal to the number of degrees I have out of 360, which would be 300 degrees out of 360 degrees, times pi times the diameter. Well, if the radius is 5, that means the diameter is 10, so I'm multiplying by 10 pi. So let's reduce this fraction. I have 300 out of 360, which is 30 out of 36, or 15 out of 18, or just 5/6. So this whole fraction reduces to 5/6, 300 out of 360, times 10 pi, which tells me that the length of the arc, when I multiply by 10, well, 6 and 10 share a common factor of 2. So that'll give me this. So the length of the arc is 25 pi over 3. So that is the length of the arc. And if I want the sector area, I'm going to do basically the same thing. I'm going to take the ratio of the circle I have, which I know is 300 out of 360, times, now it's a fractional part of the area. So if the radius is 5, the area of the whole circle would be 25 pi. So that's the area of the whole circle, and that's the fraction of the circle I'm talking about. From part A, we already know that this ratio reduces to 5/6 times 25 pi, which this has no common factors between 6 and 5, so my area of my sector is 5 times 25, which is 125 pi over 6. Okay? So anytime you're dealing with a portion of the circle, it's whatever that portion is times the circumference for the length, whatever that portion is times the area for the sector area.